Okay, it's football season, and you see the shirt I got on, you should root for them. Because when they lose, I give more homework problems. I make the test harder. Anyway, today we're going to talk about solving systems of equations algebraically using substitution. There's two methods to do systems of equations algebraically. We're going to focus on substitution today. All right? Now remember, what we're looking for is a point where two lines intersect. So you should always have a point as an answer, or you should have something that tells why a point is not your answer. But we'll get to that later. So here's my little steps that I try to give on a lot of things. How to use substitution. First of all, one of your equations has to be solved for x or y. So you need to have this in one of your equations because you're going to have two. You're going to have to have one of these. You don't have to have both, but you need to at least have one. Substitute it, and it being the equation that looks like this, into the other equation. So you never substitute it in itself. And then you solve for that variable. Once you get that, you got to substitute again. So actually there's two substitutions. Substitute your answer into one of your equations and you'll find the other solution or coordinate. And you write your x coordinate and your y coordinate as a point. And so let me actually go through that and so you can see the process. I'm going to try to solve doing substitution here. But in order for me to do substitution, one of my equations has to look like this. X equals or y equals. And I don't have that here. But notice I have a 3, a 4, a 1, and a 2 as my coefficients. Remember, there's always a 1 in front of it if there is no number there. Always pick the variable that has 1 or negative 1 as its coefficient. What do you do in a case if there's 2? Just pick one. It doesn't matter. In this case, I'm going to take this equation here and solve for x because it's the easiest. I don't have any fractions to deal with. So I'm going to solve for x by subtracting 2y. Now keep in mind, whenever you solve for x, there is no form or formula for solving for x. So however you write it, as long as the signs are correct, is okay. So now I have step number one. I have one of my equations that looks like x equals or y equals. Now substitution says, take that equation and substitute it into the other equation for that variable. So substitution says, take what x equals and substitute it in the other equation for x. So I'm going to do that. Whenever I get to x, I'm going to substitute. And I use parentheses when I substitute. 3 times 2 minus 2y plus 4y equals negative 4. Did you notice here, once I substituted, that I only have y's? There's not x and y. That's kind of a fail-safe to check. If you have more than one variable after you substitute more than one type of variable, then something is wrong. So, distributive property, 6 minus 6y plus 4y equals negative 4. Combining like terms, 6 minus 2y equals negative 4. Subtract 6 from both sides. What am I doing? I'm solving for y. I get negative 10, divide both sides by negative 2, and y equals 5. So, part of my answer is that my y coordinate is 5. Remember, your answer is a point. Now, how do I find the x? Well, it says substitute that number into any equation, that means any of the original equations, to find the other solution. But notice that this original equation was switched around to give me this. It's much easier to take this 5 and substitute it in for that y right there. So I'm going to do that. X equals 2 minus 2 times 5, and that's x equals 2 minus 10, which is x equals negative 8. Negative 8, 5 is your answer. Okay? That is substitution. What do you do if it's already like this, x equals or y equals? Then don't make the problem any harder. Just go ahead and do the substitution method. You don't have to do any work to make your equation look or be in the proper form. Okay? You can always check your answer as well by taking negative 8 for the x, putting it there, and 5 for the y, putting it there, and see if you get negative 4. Same thing for here, to see if you get 2. It has to check out for both. So you don't have to question if you've done it right. You can check to make sure you've done it right. Now, the next thing I have on here is sometimes you have special situations where when you're doing this, all your variables will subtract out. And when that happens, you have one or two options. If all your variables, y's go away, all the x's go away, if what you have left over as far as the numbers is a true statement, like 4 equals 4 or 0 equals 0 or something like that, that's a true equational statement, then your answer is infinitely many solutions. I'll let you do this if you want to. Infinitely many solutions. And if what you have left over is false, like 5 equals -2 or 0 equals 4 or something like that, the answer is no solution. And so what that means is, as we're looking for a place where two lines intersect, infinitely many solutions is if I draw a line and then I draw another line right on top of that. They intersect everywhere. They intersect at every point. And I'm being interrupted. We just had an announcement right when I was doing this. So infinitely many solutions is where the same line is right on top of itself, and they share every point. So they have infinitely many solutions. Remember, our solution is a point where they intersect. So you have to tell me that they're infinite because they're right on top of each other. No solution means that you got a line like this one here, and you got another line that runs parallel with it, but they never intersect. Remember, a solution is the point where they intersect. If they're parallel, they never intersect, so there is no solution. Remember, the answer is a point or a reason why you don't have a point. So I don't have a point if it's infinitely many because it's infinitely many. I don't have a point if it's no solution because they never intersect, so there is no solution. Let's take a look at this last example here. I'm going to do substitution on this last example here. Now, notice that in order to do substitution, one of these equations needs to be solved for x or y. And the easiest one I notice is this one right here because it's -1. That's a lot simpler, and I won't get any fractions depending on if I solve for any one of those. So what I'm going to do is subtract 6x from both sides. And I always go ahead and put it in slope-intercept form if I'm dealing with solving for y, just because that's the normal procedure. So I get y equals 6x plus 2. Okay? Now I'm going to take what y equals and substitute it into the other equation. Not the same equation, but the other equation for y. Make sure you substitute for that variable. So notice you can solve for x or y. The first problem I solved for x here. And the second problem I solved for y. It doesn't matter. Just pick the one that's the easiest to work with, and in my opinion it was the -y there. So I have -18x plus 3 times 6x plus 2 equals 4, and in parentheses is what I substituted. That's the substitution there. Notice everything else is the same, the 4, the 3, the -18x. Now doing the distributive property, you have -18x plus 18x plus 6 equals 4. Combining like terms, simplifying, I have 6 equals 4 because those two end up subtracting out, going to 0. Now the question is, does 6 equal 4? The answer is no. So all my variables subtract out. I have a false statement, so my answer is no solution. That is solving systems of equations by substitution. Go Falcons!